Ladies and gentlemen, let me welcome you to session number 6, which deals with robotics and AI. In view of militarized conflict, we have a number of very succinct talks on this issue, and Bruce Swett will start off. So the floor is yours.
If I could have the slides, please. Thank you. So first, I'd like to thank the academies for this opportunity to present, and we'll be discussing designing robots for the battlefield and the state of the art currently. And I'll be discussing a number of topics: artificial intelligence empowered robots that are currently on the battlefield, or AI robots, understanding AI and how it enables machine autonomy. So I'll present a framework that will help you understand kind of the relationships between artificial intelligence and robotics autonomy. We'll talk about the risks of AI robots in the battlefield, as well as some of the future trends. Also, we'll talk about some of the research we're doing at Johns Hopkins University Applied Physics Lab in relationships to AI robots, and then I'll offer some conclusions and some closing thoughts. So the first important piece of information is that there's currently a worldwide arms race for the development of AI robots for the battlefield that are capable of autonomous action, which is without the continuous supervision of human control. And the goal for this is to create a decisive advantage over your adversary by having a system that can give you enhanced situation awareness, understanding of what's going on around you, to increase your speed of decision making, or the OODA loop: observe, orient, decide, and act, so that you can make decisions and act on the battlefield faster than your opponent can, to increase the survivability of friendly forces, and also to enhance the destruction of adversarial forces. So the bulk of this talk will be on kind of making sure we're all on the same page with what's currently available on the battlefield across the world. So the next piece we're looking at is that there are a couple of major categories of robotic systems that are used. We all largely know about unmanned aerial vehicles, or UAVs, and these have been widely used by the US, by China, Russian militaries, as well as numerous nation states and regional actors. There's a relatively low cost, low barrier to entry. So there are huge numbers of these, and they vary in category from very small surveillance kinds of UAVs that you can have very capable systems for $1,000 up to the Reaper class, which requires global satellite communications for command and control and is largely restricted to larger nation states and those militaries. Those systems, the UAVs, can be deployed individually, in small groups, and in swarms. And they have different purposes. So UAVs have largely been used in military conflict for situation awareness, to try to understand what's going around you. But now their use in combat is kind of morphed into target identification and tracking, direct attack with missiles and bombs, command and control and communications, targeting for other weapons systems, and also even resupply. So not only is there a low barrier to entry and there's tremendous use, but the use cases for UAVs have expanded greatly. In actual combat, Russia has flown multiple types of UAVs in the conflict with the Ukraine, and has used UAVs to rapidly target heterogeneous artillery for mass effect indirect fires. Russia has also employed armed UAVs in Syria. The U.S. has an extensive history of using UAVs in combat, especially the MQ-9 Reaper, and targeted strikes in the Middle East is probably the most notable. Israel has developed the IAI Heron to compete with the Reaper, and along with China, is one of the major suppliers of drone technology worldwide. So currently, UAVs are flown from a ground station over, that could be a handheld unit or it could be a larger ground station, and that there are automated systems for creating waypoints. So think of breadcrumbs. So instead of you flying the UAV flight controls, you say, go here, go here, go here, go here. At this point, the UAV is not largely making decisions on its own. The pilot, even though the pilot is removed, is still making those decisions. But there are indications that major militaries around the world are really trying to push that, that decision-making of selection of identification, tracking, selection of targets, and automated decision-making forward because of the electronic warfare that contests the communication channels that allow that remotely piloted UAV to occur. So UAVs, as we move forward, are going to become more lethal, more numerous, and more autonomous. Now, in addition to that, on the upper right, UAVs are not the only class of unmanned vehicle. You also have ground vehicles, UGVs, and also undersea and surface vehicles, UUVs and USVs. UGVs have been used by the U.S. Army for a long time, especially in dealing with unexploded ordnance or with improvised explosive devices, IEDs, both in Iraq and Afghanistan, and the U.S. Army is purchasing UGVs in very large numbers. But more recently, that has expanded from these very small portable units to robotic tanks. Russia has fielded the Uran-9 that has both guns and missiles in Syria and had mixed results with that. And the U.S. is also developing an optionally manned platform based on, as a replacement of the Bradley fighting vehicle. So, similar to UAVs, the concept of operation is these unmanned vehicles are placed out in front of manned systems to where they detect fire and attract fire earlier, which increases survivability. They also project force and attack first so that they provide this, again, this decisive advantage. Also, by reducing the cost, by you're not engineering for a protection of a human, you can have more of them. And so this is part of the attraction for militaries around the world for these systems. Now, similarly, UUVs and USVs have been deployed several countries, US and China primarily. China demonstrated control of a swarm of 56 unmanned boats that were working as a swarm. And it's important to understand that one of the reasons this is tactically important for militaries is that you can have a large number of these all converge and attack a much larger vessel, and you can inflict disproportionate damage for the systems, in addition to not exposing your soldiers to the risk of death. You're also gaining a tactical advantage. So these, again, all require some form of communications, but those systems, because they're challenged, are pushing towards greater autonomy. Now, another system that we don't usually think of, but it's absolutely the same format, are integrated air defense systems, or IADS. Now, IADS are a combination of sensing systems like radar tracking, air missile defense systems, electronic warfare, jamming, guns, surface-to-air missiles that keep planes and helicopters out of an area. Russia has developed probably the most effective IAD system in the world. And there's really nothing but a fifth-generation fighter that can fly. It basically shoots down anything in the air. So, and these have extended range, and these have posed challenges to other militaries around the world. It's important to note that these are fully automated systems. So there is no human in the loop that is saying, that's your target, that's not your target. Anything that flies within that bubble will be destroyed. That's how they work. And the reason for this is critical, is that, I've been in conferences before where people have claimed that humans will always be in the loop. There'll always be a human decision maker. One, that's not true now. And two, it's a convenient fiction that gives us some comfort. But the two aspects that get humans out of the loop, one is speed. So if you have to respond in milliseconds, humans can't do that. So that's one of the reasons that these IAD systems exist and are fully automated. The other one we'll talk about is scale. So no human is going to individually be able to monitor 10 million tweets a minute. So humans are not in the loop now. Now, it's not just Russia, is that the US Navy has used the Mk-15 Phalanx close weapons system for the protection of ships for a long time. And that has a fully automated mode as well. And it's because it has to be really, really fast. So speed and scale are the two ways that humans are kicked out of these human-on-the-loop systems. So I wanted to present an understanding of how AI ties to machine autonomy on the battlefield. And so this is the PDAT system, Perceive, Decide, Act, Team, and Trust. And you can see at the top, there's these blue boxes of perceiving, deciding, acting, and teaming. And these are functions that the AI system needs to be able to do to produce truly autonomous behavior. And as we heard previously, from the Bosch talk, and as perception is really, really hard. For humans, it takes a third of our brain to process vision. So think of that. And we are highly tuned from an evolutionary point of view to be able to do that. Computer vision is nowhere near that capability. So perception is really the long pole in the tent, but it's also where a lot of the research has been focused. Deciding, acting, and trusting, as we've heard also, is that being able to test and evaluate and validate and verify becomes a really critical component of these systems. So there's significant research that needs to occur for these automated systems to be able to perform these functions. And I'll give you some examples of both those limitations and the risks that are involved in those. So the question is, why is it a bad idea to put a fully automated AI system on the battlefield today? And I would say there are a number of them. The first, the state-of-the-art of narrow artificial intelligence, which is what we're talking about, that's what's available today, is that it has to perceive the world. And so the ability to reliably identify friends or foe is a critical part of the laws of armed conflict. We need to be able to discriminate that. And that's very, very challenging for artificial intelligence systems to do. If there are changes in weather, if there are changes in look angle, lighting, there's so many different things that can, perspectives, not to mention adversarial AI and challenges where there's intentional deception involved. So just the basics of understanding who your foe is, where they are in the world, what the relationships and context mean is really, really challenging for artificial intelligence. And then making a decision, so in addition just to the perception layer, on top of that you have to have context. So is the person digging in the ground to place an IED, or are they digging in the ground to plant food? To do planting. So there's so many things that are challenging at that level. And then you get to action selection, is that we as humans do feed-forward predictions of the consequences of our actions all the time and evaluate alternatives. That's where ethics and principles and laws have an opportunity to enter my decision-making process. So, if a robotic arm is going to move through your head because of its motion plan, it just does that. It doesn't necessarily say, oh, I'm thinking of where I'm going to go, and then I'm evaluating the consequences of that behavior against some principle of harm. Those are things that need to be developed but are not currently available, even as we rush to deploy AI-empowered robotic systems on the battlefield today. And then we've talked a bit about the teaming and trust, and those trust factors are not only how the human and the machine understand each other, but also the effects of cyber attacks, of communications attacks, of poisoning data, poisoning reward. There are a number of ways that these systems can be compromised and will be in the near future. Now, said in conversations is that, and sometimes we think we're at artificial general intelligence, which is that we have an AI that's able to think like a human, reason like a human, have context like a human, have perception like a human. The estimates for that capability are 10, 20, 50, and never that we're going to develop that. We don't have that today. So the systems that we are actually deploying very rapidly in the battlefield are narrow AI and have significant limitations. So there are certain trajectories then that we're talking about. From a cost-benefit ratio, in the near term, it's not likely that we're going to replace humans with robots. What we'll probably do is enhance what we're doing now, and this is what a lot of the militaries are doing, is they're trying to use AI robots for dull, dirty, and dangerous jobs. So a lot of people get killed moving things around in trucks, right? So logistics, and you say, well, gosh, that's not as sexy as, you know, blowing things up, although that's a terrible term, is that a lot of things like logistics and command and control and even business models and processes are the first things that are being automated. Now, the other pieces are the augmentation of human decision making. So if it takes, you know, it takes a tremendous amount of human energy to do intelligence, to go through hundreds of thousands of hours of video and sensor feeds and data. So there's a whole world of AI in the battlefield for intelligence, and then there's AI on the battlefield for physical applications. Both are proceeding very, very rapidly. And in the near future, the use for non-physical, information-based is really the primary piece. Now there's a tremendous movement to replace human decision-making. And the reason for this is, again, back to speed and scale. So if I can have something that can, instead of 20 people flying one predator, I can have one person controlling 100 predators. Well, that changes all the dynamics of warfare. And if I can make those decisions in milliseconds instead of seconds or hours or sometimes in days, which is the current standard operating procedure, then I've gained a tremendous advantage. Now, another area that has been a priority for militaries in the world is electronic warfare. And that's, jamming and counter-jamming and detection of threats. And there's a tremendous investment in that area. So I wanted to talk a little bit about what APL's been doing. And a lot of this ties into Margaret's previous talk about how we're concerned about these things. We're concerned about, well, what's AI actually going to do? So there's one line of research called TACE, which is creating a governor to sit on top of AI systems that learn and says, if you get out of these bounds, we will turn you off. And this is specifically for UAVs, but it could be for other systems as well. And this is meant to be a kind of a bridge until we have systems that learn to conform and comply and stay within those rules. But it is one of those kinds of normative approaches that imposes external control. We also have research on what the elements are between humans and machines and teams to develop trust. And it's about task dependency, and it's about how you foster the relationships between humans and teams and machines, and then how you perform research to ensure that these kinds of relationships are built and developed in an appropriate way. Now, one of the most interesting ones that I've been a part of is this collaboration between APL and the Johns Hopkins University Berman Institute of Bioethics about really, can you build an AI system that can perform moral reasoning, and what would that look like? So we had a philosopher, ethicist, a governance person, roboticist, AI person, a human-machine interaction person, all teaming together, and it was just really interesting. And we did start with the Isaac Asimov first principle. How would you have a robot? How would you actually code something that would say, a robot shall not harm? How would it learn what that means? And it starts again with perception. And so how would it perceive that something is alive versus something is dead, or that something has a mind and it has the perception of pain and can be harmed? What are then the types of harms that could be done to a living, experiencing mind? So you have this whole kind of an ontology that fell out from that. It was very interesting, that crossed disciplines to be able to say, well, yeah, we can create a robot that can perceive living versus non-living things with some reasonable amount of accuracy. And then what are the implications that come from that and how it behaves? So does it hand you the pointy, the scissors point first, which is a threat because humans can be injured by pointy objects, or does it behave differently because you're a human that can be injured? Very interesting research, all still very nascent. So in coming to the end of this, a couple of conclusions. One is that it's kind of a grim prognosis if you're looking at future trends. There's rapid advancements in the field of AI robotics that has not really followed on with ethical discussions or even test and evaluation and verification. These capabilities are becoming more prolific and more lethal, and wars will be fought at machine speeds, faster than humans can process that and make decisions. There will be hundreds of thousands to millions of these UAVs, USVs, UGVs, and so on, that will be semi in the control of humans. And this proliferation will be across nation states and regional actors and boundaries. So these trends have started, but we don't know what the future will hold. So I'd like to conclude with a couple of thoughts. And this ties back into movies and science fiction, where we get a lot of our projections of the future. And the predominant one in the United States has always been Terminator. That, that the vision of the future is that we're going to create something that we can't keep up with, that's going to dominate us and ultimately destroy us. And that's the leading vision. Now, it's important to say, we were discussing yesterday, that Japan doesn't have that. Is that in the Japanese mythology and folklore around robotics, is that humans are always causing problems, and the robotic systems are actually the heroes. So it's very culturally dependent. So another vision that people have raised concerns about is that, are we raising AI robots to be a slave race, right? We as humans have a terrible track record of dealing with the other, and what we consider to be not human, less than human, other, and our history of destruction and subjugation. So I would like to offer a third option, because I think those are both unacceptable, and we've talked about this term coevolution a number of times, and I think it's a remarkable term. Part of this is that I see the development of artificial intelligence towards artificial general intelligence as like the biggest mirror for humanity. And you look in the mirror, and we can certainly see our own destructive tendencies, how we deal with people. But we can also see that there is the possibility for improvement, for regeneration, for development, for growth. And we need this as humans. So another vision of the future would be that we could choose as individuals to learn about ourselves by learning about AI, learn about why we are driven largely by a very primitive affective emotional system that causes us to wage war and to dominate and destroy. We could also learn how to process information faster. We could improve ourselves. And in doing this, we could alleviate the fear of the other two scenarios. If we are able to enhance ourselves as we move forward, we could keep up with AI, and then we could ensure that AI complies with our ethical norms, our values, our laws, because we would be peers, not subordinates. So we wouldn't be subjugated, but at the same time, understanding ourselves and being able to have this kind of reflection would give us an opportunity to improve. So while we're currently involved in a global international arms race to create the most destructive and autonomous artificial intelligence robots, I don't believe that has to be the future. I think this coevolution and use of AI for enhancement of not only humans, but the human condition, dealing with issues of social justice and inequality, is a much more constructive path. Thank you very much. Thank you.